Good day everyone, this is our final project presentation on Advanced Database System. I'm Presentation-Balaan and my partner is in this project is Ms. Talosig. The content of our presentation is first data cleaning and data processing. Next, data statistic and visualization interpretation. Next, how we create our model and rapid miners. And the next is interpret model results and also how to convert non-numerical data into binary number. The data we are going to use is the data of morbidity cases consists of the types of illness, symptoms, doctor illness, diagnosis, date of checkup, categories of illness, prescribed medicines, and the treatment of control. It consists of 3,995 datasets. For the data cleaning, the data pre-processing, first thing we will do is make the data on symptoms, doctors, illness, diagnosis, categories of illness, prescribed medicines, and treatment. And control a proper case. To do this, add another column and use the formula equal sign, then the word proper. Next is that open and close parenthesis. Inside the parenthesis, put data on the cell to do make made proper cases. Just to do this process on the symptoms, doctor illness, diagnosis categories of illness, prescribed medicines, and treatment and control as seen in the video. The next we are going to do is to combine data on one column. To do that, use the formula star with an equal sign and the word concatenate and open close parenthesis inside the parenthesis. Enter the data you want to combine, and to combine the data properly, put a space or comma between the data to do this in the formula. Put a double quotation after the commas and put a comma or space inside a quotation just to do this process in symptoms, prescribe medicines, and treatment and control. Next, to remove duplicate word in the combined data. To do that, we manually or do it each column. Find duplicate in each column, then edit the formula, remove the cell of duplicate word if there are two or more duplicates data, and leave one or of each the data as seen in the video. Do it also in prescribed medicine and on the treatment and control. Last we are going to do is data cleaning and pre-processing in the data is remove duplicates in the entire data. To do that, highlight all data or just do the control A and go to the data tab and find the remove duplicate. After clicking on remove duplicate, you will see the selection of the duplicate to do remove. Just select all the click OK. After that, it will show how many duplicate will remove as seen in the video.
To load clean data in RapidMiner, open RapidMiner Studio. Click the blank process and find the import. It appears to be where is the data. For that, click my computer because our data is saved in the computer that we are using. After clicking the location of the data, shows the file manager of the computer. In this part, we find and select the data we want to load in RapidMiner Studio. After selecting the data, click OK. After that, it shows the data and then asks what cell are we going to import. But we don't need to select a particular cell because all the cells in the data are going to load. So that just click next and next. Next that is where you select the location where the data will be saved in the RapidMiner. In that case, we select the data as a location of our loaded data. Then click OK. After clicking OK, it shows the loaded data are already in RapidMiners.
In the data section, you will see the entire dataset is displayed on. In this picture is show that we have 177 sample of data, 0 special attributes and 7 regular attributes. The 7 attributes are types of illness, symptoms, doctors, illness diagnosis, date of checkup, categories of illness, prescribed medicine, and treatment and control. The 177 examples are the data of all 7 attributes. Statistics interpretation. This operator calculates our basic statistic and distribution for all columns of the input data. The techniques often include calculating descriptive statistic like mean, standard, the deviation, variance, or minimum or maximum, and univariate and multivariate analysis using different vari- visualization. In the statistics section, we can see the descriptive statistics like minimum, maximum, average for each attributes and the number of missing values as well. In this picture, it shows the 7 attributes in the data. We can see also the type if it is nominal or integer of each attribute. It say that there are 6 nominal attributes, 1 integer attributes. We also see the amount of values of data in each attribute. It says also that there is no missing data. The visualization tab of the results section in Studio allows to do config our plot settings, from adding color to multiple access and configuring tooltips and labels. In this visualization, we use scatter bubbles as plot types in anal- uh, analyzing data, and x-axis column was the type of illness, and value column has the doctor illness diagnosis, and the color has also and the types of illness. As the analysis in the results, most of the doctor's illness diagnosis were non-communicable disease types of illness, while 5 of the doctor illness diagnosed were communicable disease type of illness. In this visualization, we are again the scatter bubbles are plot type in this graph. We use now as an x-axis column that categories of illness, and the value of columns was the prescribed medicine. As an analysis of the graphics, we can see we can say that most of the categories of illness, acute upper respiratory infection, has many prescribed medicine. We assume that 60% of prescribed medicine has the acute upper respiratory infection category illness. We also have an assumed 15% of prescribed medicine have a category illness of influenza. There is also hypertension. We assume that 10% of prescribed medicine have.
In creating model, we use decision tree. A decision tree is a tree like collection of nodes intended to create a decision on value affiliating to a class or an estimate of a numerical target value. Each node represents the splitting rule for one specific attributes. In creating model, open rapid miners, start new process. The first thing to do is retrieve the clean data. After retrieving the data, the next thing to do is set the role of the data. Retrieved data must be connected to set role as seen in the first picture. After inputting the set role operators, double-click and we can set the role of the attributes. In this data, we set the doctor's illness diagnosis as a basis and put its role as a label, then click Apply. The next step is put the split data operators. Set role must be connected in split role as we see in picture 3. After putting it, double-click and we can edit the partition of the data. We put zero point 0.7 or 70% of the result of the performance and zero point 0.3 or 30% in testing the model. After editing the partition, click Apply. As we see in the picture 4. The next one is putting algorithm. Input the decision tree algorithm and connect and must be connected in the split data as we see in the picture 5. The last one is to put the performance operator, and it must be connected to the decision tree to perform the model and in the split data to testing the model as we see in picture 6. Performance must be connected to the result and now run the model. As we doing the step in creating model using decision tree algorithm, this is the final model. After the connection and setup of the model, click Run and we can see the result of decision tree and the performance of the model in the data. In analyzing the decision tree result, if the type of illness is non-communicable disease, most of it is hypertension or 100% non-communication disease. Otherwise, if the type of illness is a communicable disease and its category of illness is acute upper respiratory infection, then the doctor's illness diagnosis is common cold. Otherwise, if the type of illness is communicable disease and the category of illness is conjunctivitis, then the doctor's illness diagnosis will be sore eyes. Else, if the types of illness is communicable disease and its category illness is tuberculosis, then its doctor's illness diagnosis is the same as tuberculosis. Therefore, the majority of the doctor's illness diagnosis come from the non-communicable disease which is hypertension. And in communicable disease, we can say that the most common diagnosis is the common cold as we see in the picture. In interpret model result for the performance vector result, in the performance vector, we will see what we call the confusion matrix. The confusion matrix is a crucial part of the performance evaluation in the classification. It shows the numbers of true positive, true negative, false positive, and false negative, providing a detailed breakdown of the models performed in each class. The model gives an accuracy of 54.55% of the data, as we see in the picture 1. In the picture 2, they also show the class record of the data in the performance. It shows that there is 100% recall and there is 0%. We can say that the model correctly we can say that the model correctly identify all relevant instance in the data. In converting non-numerical into binary, we assign binary numbers in each of the columns. After assigning binary numbers, Ctrl F and enter which you want to convert, then in the replace, input the binary you assign the data. After clicking the replace all the same data you enter into their assigned binary. After clicking replace all, it shows us how many they replaced and click OK. Now we can see the binary assigned in the data.